Hey guys, today we're taking a look at negative rational exponents. Now remember, yesterday we looked at positive rational exponents, in which we took both a power and a root of the base. Well, today's lesson really is a culmination of everything that we've learned about so far in terms of powers and roots. So before we jump in, let's remember a few of these exponent properties. Anything raised to the 0 power is equal to 1. X to the negative n power, well, whenever we have that negative exponent, it really just means we're going to take the reciprocal of our base, so now 1 over x, and raise it to the power of the positive exponent. So this is 1 over x to the n. Then, yesterday, we had this positive rational exponent. X to the m over n really represents the nth root of x, so x to the 1 over n, all raised to the nth power. And then keep in mind the numerators represented the powers, or the exponents, and the denominators represent the roots that we are taking of that base. So let's jump into a few examples from today and see where this lesson is taking us. We want to evaluate 27 over 1,000 to the negative 2/3 in 3 different ways. So the first way is to handle that negative part first. So we'll have 27 over 1,000 to the negative 1, and then we're going to raise that to the 2/3. So remember, our negative exponent just switches our numerator and our denominator. So we'll take the reciprocal of that, and now this is going to be raised to the 2/3. So this is really 1,000 over 27 to the 1/3, and then we're going to square that. So this means we're going to take the cube root of 1,000 and 27, so that's 10 over 3, and raise that to the second power, which is 100 over 9. So here's one way to evaluate that. And notice we took the negative and evaluated that first. So another way is to, instead of starting with the negative, let's start with the 1/3. So we're going to take the cube root, and then we're going to take that to the negative second power. So the cube root of both 27 and 1,000 is 3 over 10. And now we're going to take the negative of that piece and then square that. So remember, those negative exponents just make us take the reciprocal of that base. So now it's going to be 10 over 3 instead of 3 over 10 squared, which again leads to 100 over 9. And finally, our last method is we can square everything first. So we can take 27 over 1,000, square it, and then take the negative 1/3, or the negative cube root of that base. So when I do that, I'm going to end up with a very large number. This is 729 over 1, 2, 3, 1, 2, 3. That comes out to 1 million. And now this is going to be raised to the negative 1, and then we're going to take the cube root of that. So the negative 1, again, just makes me flip the top and the bottom, so the numerator and the denominator. And now I'm going to do the 1/3 power of that, which is the cube root of both of those. And when I do that, I end up with 100 over 9. So again, what you should end up with is the same answer no matter which method you use. All right, let's try our next example here. Example 2 says to simplify each of these, knowing what we know now about negative rational exponents. So 5 to the negative second power is 1 over 5 squared, and that results in 1 over 25. 10 to the negative third is 1 over 10 to the positive third, which results in 1 over 1,000. Now 125 to the negative 1/3 is 1 over 125 to the 1/3, which is the cube root. So this is 1 over, the cube root of 125 is 5. So this is 1/5. All right, let's try a few more examples here. Following along your notes, it wants you now to evaluate 32 over 243 in the 3 different ways that we did in example number 1. So I'm going to set up a few of these, and I want you to finish them off, and we can check your work tomorrow. So the first one, we have 32 over 243. We're going to do the negative 1 first, and then raise that to the 2/5. So this is 243 over 32. Now we're going to take the fifth root of that and square it. So go ahead and you finish off that, the fifth root of both the numerator and the denominator, and then square both the numerator and denominator. The next method you can set up is 32 over 243. Let's take the fifth root first and then raise that to the negative 2 power, which results in 2 over 3 to the negative 2. I believe, yeah, let me just check my notes there. And then that's going to give you 3 over 2 to the second power. And again, you can finish that one off. And then finally, our last method here is 32 over 243. Let's start off by squaring both of these. And then, then we're going to need to raise that to the negative 1/5 power. So I will let you finish off that one. We'll check all of those tomorrow in class. Now there are a few more examples we want to go through with you. So let's start off by simplifying this 25 to the negative 1/2. Again, let's handle the negative piece first. That means it's going to be 1 over 25 to the 1/2, which is 1 over 5. 36 to the negative 3/2 is going to be 1 over 36 to the positive 3/2 now. So let's take a second to evaluate. That's 1 over 36 to the 1/2, and then we're going to cube that. So 1 over 6 to the third power, which should give us 1 over 216. All right, let's evaluate letter C. We have 64 over 125 to the negative 4/3. So I'm going to get rid of the negative part first by taking the reciprocal of my base, so 125 over 64. And now I'm going to take the third root of that and then raise that to the 4th power. So this becomes the third cube root of 5/4 all to the 4th power, and that's going to result in 625 over 256. All right. We can use these negative rational exponents to solve equations as well, similar to what we did with positive rational exponents. If I wanted to solve for x here, I need to undo this exponent. So I have x to the negative 3/2, and I want to just solve for x. So I want x to the first power. So that means I need to take a power of powers in such a way that when I multiply these, my exponent on x will be equal to 1. So I'm going to multiply by the reciprocal of that exponent. And again, in algebra, what you do to one side, you have to do to the other side. So I'm going to take 18 and raise it to the negative 5/3. This leaves me with x to the first power is equal to the cube root of, so this is 1/3, then raised to the negative 5th power. And that is 1 over 18 to let's try this again here. I got to erase that. That is the cube root of 18. So this is going to be 18 to the 5/3 power. So we're going to show you how to do this here on your graphing calculator. This is one that you're going to want to use to help you along. So if we're going to say that x is equal to 18 to the negative 5/3, then you can simply type in 18, raise it to the power of negative 5 divided by 3, and your calculator will return that answer to you, 0.008. So this is equal to 0.008. All right, let's try our next one here, letter B. We have x to the negative 2/3, and we want to solve for x. So I need to raise it to the reciprocal of that power, negative 3/2. So 16 to the negative 3/2. And we're going to complete this one by hand here. So let's start off by taking the negative away by getting the reciprocal of that base. And now this will be raised to the positive 3/2, which is the square root of 16 cubed. So that's 1 over, the square root of 16 is 4, 4 cubed is 1 over 64. So our value for x, this one, is 1 over 64. All right, 2 final examples here. We want to give you guys a chance to do these ones on your own, very similar to the previous examples. Check your work in class tomorrow, and good luck.